Hi, we are looking at the Chapter 1, Sections 4 and 5 note packet, and we're looking at the angle pairs. And this is going to be a lot of really important vocabulary that you're going to use again and again and again. So the first pair of special angles are adjacent angles, and adjacent angles are going to be two coplanar angles, gotta be coplanar, with a common side, a common vertex, and no common interior points. In other words, there is no overlap for these two angles. They do not share anything besides the side and the vertex. So in this picture, examples of adjacent angles would be angle 1 right here and angle 2 right next to it, right next to each other. Angle 1, this little guy, and angle BDQ, this big angle. Okay? Angle 2 and angle 3, of course, are adjacent, etc., etc. Also take a look at some angles that are not adjacent. Angle 1, which if we were to redraw it here on the side, would look like this. And then angle MDQ, which if I use my highlighter to do that, angle MDQ in our picture would look like this. And angle MDQ then would not only be sharing a vertex and a side with angle 1, but unfortunately, using my other highlighter, they also share everything inside of angle 1. Therefore, they are overlapping, and those would be not adjacent angles. Okay, so again, take a look at the other angles that are listed here and keep in mind that those are not adjacent angles. Okay, our second pair are complementary angles. My apologies because your copy, the red wasn't coming out of my printer, so I had to hand write them, but your copy has the numbers. So complementary angles, again, are two angles that with measures that add to be 90 degrees. Notice in this picture, 15 and 75, of course, add to be 90, and these are two adjacent angles that are complementary. In this picture, and I'm going to make a note of that actually, these are adjacent complementary angles. But in the second picture, you'll notice your two angles, 35 degrees and 55 degrees, also add up to 90, but they're not even touching each other. And you want to keep that in mind as you're looking at this stuff, that you do not have to be adjacent to be supplementary and complementary. It's not about location, it's about measurement value. Okay, we'll make a note about that. Not about location. Just measure. Oh, barely going to squeeze that in. Not about a location, it's just about the measure. Okay, our last pair on this page are supplementary angles. And supplementary angles, again, they're two angles with measures that add to be 180 degrees. So here's a lovely set of supplementary angles. These two happen to be adjacent to each other, and we'll have a special name for them on the next page. And then the second pair, again, not touching, but still add up to 180 degrees and therefore still supplementary. Okay, we're moving on to the next page and more pairs. Okay, on this page we have our next special pair. That's a linear pair. And linear pairs are two adjacent angles whose non-common sides are opposite rays. Okay, so take a look at this picture right here. These two angles, angle 1 and angle 2, those are both a linear pair. And the picture you want to think of is, again, this straight line. So here are the two non-shared sides that are opposite rays. And again, they're forming a line, and then you have your 1 and 2 here, your adjacent angles, okay? So adjacent angles, and they again form a line, hence the name linear pair. Vertical angles are two, and this is a weird definition, two non-adjacent angles whose sides are opposite rays of each other. So those are going to be vertical angles. I will never ask you to define vertical angles because it's a crazy definition, but I will ask you to find vertical angles in this picture. So you'd want to say here, let's go ahead, this is a linear pair. And over here in this second picture, our vertical angles would be angle 1 and angle 3, and angle 2 and angle 4. Okay, notice 1 and 3 are not adjacent, but the sides of 1 form opposite rays with the sides of 3. You can also always think of this situation where two lines cross each other. You're always going to get two pairs of vertical angles when that occurs. Okay, and then the last thing on this page is asking you to name two sets of linear pairs in the picture and name two pairs of vertical angles. You should do that before you move on to the next page. Go ahead and stop the video, and then you can find the answers, the possible answers, on the next page. Alrighty. To go along with our special angles, we also have a postulate that we are going to use constantly when we are dealing with proofs later on in the upcoming chapters. So the first one's the linear pair postulate, and it says if two angles form a linear pair, then they are supplementary. So in this picture, I can just look at the picture I can say, based upon the picture, angle 1 is supplementary to angle 2. And then I would justify that statement. I would give a reason for that statement. I would say, I can say that because of the linear pair postulate. Okay? Now, be careful, because in proofs, it's going to take one more step to come to the next conclusion, and this is going to happen to you 99% of the time. You're going to take a sentence and you're going to translate that sentence into an equation. So I would then say, I can say, the measure of angle 1 plus the measure of angle 2 is equal to 180. And the reason I can say that is because, back on the previous page, I know that being supplementary means you add up to 180. So I'm going to say this is because of the definition of supplementary angles. Okay? So keep those things in mind. You're going to use this particular sequence quite often when you are doing proofs. Okay, the last definition, again, also going to be one that you use constantly, and that's for the bisector of an angle. Let me go ahead and box this linear pair postulate, and then let's go ahead and highlight also this bisector of an angle, because we're going to be using that definition a lot. So it says it's a ray that divides an angle into two congruent angles. So the endpoint of the ray will be on the vertex of the angle. So in this picture, if we are told ray BD bisects angle ABC, we can conclude that these two angles are congruent to each other. The way that we mark angles congruent in a picture is we make little arc marks across the congruent angles. So we would say this angle is congruent to this angle. We can use single arc marks, we can use double, triple, depending on just how many different pairs of congruent angles or sets of congruent angles that you have. Do try to stagger your arc marks. Otherwise, if you make them right next to each other, it looks like this big angle is congruent to something else that we can't see. So again, stagger your arc marks. Also, we can say that segment BD is a bisector of angle ABC because again, it's also going to separate this angle into two congruent angles. Again, notice we're giving a reason for why we're saying. Also keep in mind that this definition could go backwards. If I told you that you had this picture and I said that angle ABD was congruent to angle DBC, then you could say that ray BD bisects angle ABC because of definition of an angle bisector. Okay, so keep that in mind that this definitions can work both directions, whether it's forwards or backwards, and you will be applying these as we move on. Okay, the rest of the packet has examples in it, and we will be going over those examples in class. So I will see you in class.